According to the theory of evolution, the origin and development of the universe and all its systems can be explained solely on the basis of time, chance, and continuing processes. All living things have arisen from a single-celled organism. A second and opposing worldview is the concept of creation. According to the theory of creation, everything in the universe has come into being through the design, purpose, and deliberate acts of a supernatural creator. That means this creator created the universe, the earth, and all life on earth, including all types of plants and animals, as well as humans. Join us for today's edition of Origins as we explore the center of the universe.
Hello, my friends. Welcome to Origins. My name's Don Chapman. I'm so glad that you've joined us. Origins is a forum where we take the evidence of science and we use it to validate the truth of creation. And today we have with us Dr. Russ Humphreys.
Glad to be here.
So good to have you with us.
Always a pleasure.
Now, you are, just for folks who are joining us, in 1959 you were one of 40 winners of the Westinghouse National Science Talent Search, and you got your Bachelor of Science from Duke in 1963 in physics, and then you went to LSU, and in 1972 LSU gave you a PhD for your research. Tell us about that research. Cosmic rays.
It's cosmic rays slamming into nuclei, atoms in the atmosphere, blowing them apart, and we pick up the pieces and try to figure out what happened.
It sounds fascinating. You got your PhD for picking up the pieces.
Yes.
Okay, very good. And then for 6 years you worked for General Electric in their high voltage laboratory. You worked from 1979 through 2001 at the Sandia National Laboratories. And there you just studied little things like nuclear physics, geophysics, pulse-powered research, theoretical atomic and nuclear physics. You're the holder of 3S patents. You won 2 awards while you were working there for excellence in contributions to the light-ion fusion target theory. Then you left all of that to work in the field of creation science research.
Yes, it's been a real hoot.
And so now you are working with Creation Ministries International, CMI, and you're quite a gift to the Church of Jesus Christ. We're so thankful for you and for your work. Today we're going to talk about the center of the universe. You know, I know at least a half a dozen people who will assume immediately this show's about them. But it's not about any one individual, is it?
No.
But it is about our universe, the one we live in. Help us, first of all, just with some terms. I think people, when we talk about galaxies and universes and so forth, get them mixed up. So
we'll
begin at the beginning.
We'll begin at the beginning. I'll give this jawbreaker of a sentence. It's the title, Our Galaxy is the Center of the Universe. A galaxy is a cluster of about 100 billion stars.
100 billion stars.
But
and ours is the Milky Way galaxy?
Ours is the Milky Way galaxy, the one we're part of. And ours looks a lot like this. And they're 100,000 light years across. They're big things.
Yes.
But there are at least 100 billion galaxies within sight of the Hubble Space Telescope.
Wow.
And each galaxy is like, 2 million light years away from the next. And this, in fact, is our nearest neighbor galaxy, Andromeda, and it's 2 million light years away from us. So that's a galaxy. Now, the universe is all that whole bunch of galaxies, however many there are. It's the physical universe that God made that we're in. And,
it's everything that we can see and know that exists and beyond.
Yeah.
Is that God has made that we're aware of, and it's a part of this creation. That's the universe.
That's right.
Okay.
Now, quantized redshift, that means bunched in bunches.
Okay.
And redshifts, I'm going to get into what those are, but there's something that's observed in the light from distant galaxies.
Well, why don't you go up to the board and
Okay.
show us about redshifts?
Good idea.
And the light. I think that might be really helpful to us today.
Light waves from distant galaxies are longer. They have a longer wavelength. They're redder than normal. And here's what an astronomer sees when he peels apart the light he sees from a distant star, a distant galaxy, into different colors, like a prism and a rainbow.
Right.
He'll see a rainbow background like this. Let's see if I can circle it. He'll see, from a far galaxy, he'll see a rainbow background, and he'll see black lines on it. Those black lines are from hydrogen atoms that are between us and the galaxy that are absorbing the light. And they occur in a certain pattern, and that's called the spectrum of hydrogen. But in the lab, we see the same spectrum, but it's not quite in the same part of the colored background. So we see the black line here instead of here. And so the farther away the galaxies are, Hubble found back in 1929, the more this shift toward the red side of the spectrum is. So that's a red shift. So that's what redshifts are. Let's move on. Now Hubble also found, as I was saying, that the distance has something to do with it. That distant galaxies, he found a way to measure how far away the galaxies were from us, and then he noticed that the further the galaxy, like this one out here, what he thought was about 6 or 7 million light years, this one out here had a fairly large redshift. So this is plotting redshift this way. And so the further the galaxy, they tend to fall on that trend line. You see the background?
Yes, sir.
Line. Now some nearby galaxies happen to be moving towards us, and that makes another kind of redshift, like Andromeda is moving towards us. So that gives a blue shift instead of a red. But the further and further away these galaxies are, the more this overall cosmological effect takes place. And so that's called the Hubble law. The bigger the distance,
the greater the redshift, the further away.
Yeah.
Okay.
That's it exactly.
All right.
So now we know what redshifts are and Hubble's law is. And newer data besides Hubble's, they've corrected some of the distances, but the trend is still there. So here's a plot of distance. Only now we're at hundreds of millions of light years. By the way, a light year is 6 trillion miles. It's how far
light travels.
A light beam today would travel in 1 year. 6 trillion miles. And the percentages here are larger on this scale because the distances are larger. Percent means 3% shift toward the red side of the spectrum, and they have other ways of measuring distances, and all the galaxies they see still fall on that line. So
Okay.
that's something that nobody doubts today who studies this matter. So Hubble's law works. Now, this is something they only found out in the mid-1970s. And it was controversial for a while, but now astronomers who know about the problem, it's a problem to them. They know this, but other astronomers haven't kept up with it, and they're not too sure about this situation. But astronomers who've studied it, they have confirmed that the redshifts that we see are in regularly spaced groups. So this is the percentage redshift along the bottom here. And this is just one sample set of numbers. And this is number of galaxies they see at a given redshift. So here's a group that's at 0.024% redshift, and then another group at 0.048 redshift, 0.072, 0.096. And the guy who first discovered this is named William Tift. back in 1976 in Astrophysical Journal. Now, a lot of astronomers haven't kept up with the problem, but in 1997, two astronomers named Napier and Guthrie really confirmed this very well. They had a good technique, and they found that there were very distinct bunches. It's not just statistics. And in between the bunches, there's not many galaxies with these other redshifts.
Galaxies out there seem to be bunched.
Yes.
There's
well,
gaps between them, and then there's a bunch of them.
That's my explanation.
Okay.
The Big Bang people don't like that explanation, but we'll get to that.
That's your understanding
but
of the data.
The redshifts from
Yes.
the galaxies are bunched.
Yes.
And what I'm proposing is that the redshifts
Okay.
amount to groupings of distance. So Hubble's law would change the groups of redshifts into groups of distances. And so this is my suggestion. So the redshifts transform into actual distances. So we might have one set of intervals here, one at 3 million light years, another at 6 million light years, another at 9 million light years, but we don't have too many in between those bunches of distances. So that's how I'm proposing to explain this thing called quantized or bunching of redshifts.
Okay, sir.
So what does this mean? Well, it suggests that the galaxies tend to form concentric shells around us, because this effect, this bunching, is the same in all directions. So we see.
Now that's going to become very important. It isn't.
Yeah.
It's uniform in all ways around us.
Right.
Okay.
Yeah. So we see, in any direction, we see the same bunching occurring. So that suggests that the galaxies, you know, this might be like, say, 3 million light years away from us, and here's our galaxy here, and then another at 6 million light years away from us, and another at 9 million. Now, those are just sample numbers. There's actually it's a lot more complicated than that. There's several sets of numbers to worry about, but I've just simplified it to one set.
Fair enough. Moving away from the center would change the distances.
If you were in a forest and you had a bunch of trees around you, all at about 3 yards away, and then another set of trees at 6 yards away, and another set at 9 yards away, you'd see this equal set of distances if you were near the center of the arrangement. But if you move away, you wouldn't. If you were offset, then you'd see some trees at 3 feet, another at 3.1, another at 3.2, so on and so forth. And it would smear out. So if we offset the Milky Way a little bit in this simulation, then we get a different set of numbers about the bunching.
All right.
And so this is just the result of the computer simulation. Moving away from the center would smear those distance groups. So viewed from the center, we see the distinct groups. Here I've got 62 million light years, 64, 66, 68, versus number of galaxies that way. But we move off from the center, and the computer simulation shows us that we've smeared out those distinct bunches into something that's pretty random.
And your conclusion from this, if I'm hearing you, is that it is a way of showing that we are, in fact, in the center.
Yeah, this strongly suggests that we're in near the center of a concentric arrangement of galaxies.
That's fascinating. And we're going to see what that means and look at it a little more closely. We're going to go to a break. We'll be right back, but you want to be with us when we come back, because this is fascinating stuff. See you soon.
Creation versus evolution. You weigh the evidence. Amazing DNA. It beats computers. A computer can hold billions of bits of data, but DNA the size of the head of a pin contains enough data to fill a stack of books reaching from the Earth to the Moon 500 times over. Now think of the billions of dollars and hours of research it took to develop the computer. No scientist would ever look at a computer and think it was the result of chance random processes. Yet these same scientists look at DNA and insist it arose through evolutionary processes. Today's guest on Origins, Dr. Russell Humphreys, is a physicist and speaker with Creation Ministries International. Russ did scientific research for 22 years at Sandia National Laboratories and has published some 20 papers in secular scientific journals. He is the author of Starlight in Time, where he proposes a model for a young universe. Book orders are being taken at 800-616-1264. Russ has also been involved with the RATE Project, which has produced breakthroughs on the subject of radiometric dating. Dr. Humphreys can be reached at Creation Ministries International, P.O. Box 350, Atlanta, Georgia 30127, or visit the website www.creation.com.
We're back with Dr. Russell Humphreys, and he's been talking to us about the center of the universe, which he believes our galaxy is, and he's done that by measuring redshifts and the bunching of redshifts. Dr. Humphreys, give us your conclusion to that. You believe we are amazingly close to the center of the universe.
That's right. We would have to be within 1 million light years of the center of this arrangement, or we would not see these bunched redshifts that we see. Now, a friend of mine, Dr. John Hartnett in Australia, studies cosmology, and he has shown that on an even larger scale than I'm talking about, we see actual pieces of concentric spheres of galaxies, vast spherical arcs, pieces of spheres pointed towards us.
Amazing.
At the center. So when I say we, I mean us, the Earth, yes. Our galaxy.
Our galaxy.
And we would not see this pattern of redshifts unless we were within 1 million light years, and that's small potatoes if you're a cosmologist.
It is. It's a long ways, but not for a cosmologist.
So if you think of a universe 40 billion light years in diameter, you are here.
Right in the center. That's amazing.
And the probability of that happening by accident is less than 1 in a trillion.
Wow, that's incredible. Now, I'm looking ahead, peeking ahead here, and from our conversation previous gone on the air, I'm discovering the Big Bang Theory folks don't like to know we're at the center of the universe. Is that right?
Yes, it's because of that probability. You see, if we are in a special place in the universe, and it's very unlikely that we got there by accident, then somebody probably put us there.
So we're back to design. Okay.
So that's why they don't like it. And they have constructed the Big Bang Theory so that it cannot have a center and it can't tolerate a center. Now we get into tough stuff here. We're going to go into an extra dimension. Just take our three-dimensional universe and squash it down to 2, so that now we're flatland creatures on a flat universe. Now wrap that into a sphere, and our galaxies along with it, and imagine it's the surface of a balloon.
Okay.
So our whole universe is just that surface, not inside it, not outside, but only on the surface. So we've forgotten about one dimension here to picture it. So our space is only on the surface, and in the Big Bang Theory, there is no center on that surface. There's nothing even like the nubbin that we use for the balloon. So it's all pretty much the same everywhere, and they cannot say that one place is the center, and they don't want one place to be the center. So that's a hard concept for people to grasp. But if you have trouble with that, go to your nearest Big Bang theorist and shake him by the coat lapels and make him explain it to you.
Okay.
It's his theory, not mine.
But what you're really saying is, though, that it's not compatible. The one is not compatible with the other.
Right. And so this explanation that I've offered of the quantized or the bunched redshifts cannot be used by the people who want to have the Big Bang theory be true. So they're left without an explanation at the present.
Explain to us, or at least summarize, the central position being scientifically important.
It's important because we can't explain the quantized redshifts without something like that, yet nobody else has done it. But it's evidence against the Big Bang theory. So having a center just does away with the Big Bang theory if there is one. But it's also evidence that the cosmos has a center, and the Bible hints at this pretty strongly in Genesis chapter 1. So I have something I've introduced called the white hole cosmology, and now I've introduced another more recent one. And John Hartnett has 2 that he's now introduced. they're all universes that would have a center. If you have a center of the universe, you get a completely different set of cosmologies than you do with the Big Bang. And another by Robert Gentry, he has galaxies orbiting around us. So having a center just changes cosmology overwhelmingly. It's just a huge change. There was a relatively recent, about 2003, introduction by secular cosmologists of one similar to mine. Now, it didn't go anywhere. It was not very popular, but they considered that we were inside a black hole, that the whole universe was inside it, but we weren't at the center in their cosmology, but there was a center. So their idea was that the whole cosmos expands out of a white hole, just like my cosmology, that it has a center, and also that this abrupt expansion made shock waves that made the galaxies in spherical rings. So my cosmology would have a lot of the same features.
That's fascinating. It seems like they're moving your direction.
Well, they were, but no one welcomed this. And
is it because it's just too much to give up if it were true?
Yes. Yes, it's philosophically and religiously important to the Big Bang theorist to have a universe with no center.
Because no center implies no purpose, no design.
It implies that we're not at a special place.
That's right. We're nothing special.
If we're not at a special place, then we don't have to have a God putting us in a special place, etc., etc.
Gotcha.
So our central position is spiritually important. It refutes the secularists. Carl Sagan, you may remember, had a book called The Pale Blue Dot.
That's right.
He mentions phrases like this throughout the book. The delusion that we have some privileged position in the cosmos. I'm sorry, I can't duplicate his accent, but you know, imagine Carl Sagan saying this along with billions and billions, okay? But if we have a central position, you see, Carl Sagan's whole thesis went down the drain. And it affirms Scripture, because Genesis 1:6 says that the whole universe started in the midst of a large body of water. In the midst. And so our position would be at that center, according to Genesis chapter 1. And then the whole creation was subjected to futility when Adam sinned. You know, the whole creation groans and travails.
Right.
We have some central spiritual position. So it fits with us being in also a central physical position. So this is a battle that's been fought for 400 years. I have a journal article that gives more details. Our galaxy is the center of the universe, quantized redshift show, for people who are interested in the technical details. And that's at creation.com. And you look up the Journal of Creation, and then you look up the August 2002 issue of it.
Very good. The redshift groupings that you talk about seem to be irrefutable evidence. How does the Big Bang, how do they explain it?
Well, basically they say there must be some other explanation.
Yeah.
And that's it.
But they don't know what that is.
No.
And they do have to acknowledge that the grouping seems to be there.
Yeah, the ones who are in the know do. There's a lot of not very well informed astronomers who think that the issue was settled a long time ago and that it was just statistical. But they hadn't kept up with abreast of
the more
events.
the evidence accumulates, the clearer the groupings become.
Yes. And they also, with John Hartnett's evidence, it's almost indistinguishable, undeniable that there's a large-scale grouping. So bottom line of what I'm trying to say is that these quantized redshifts restore mankind to a central place in the cosmos. You know, in Psalm 8:3, when I consider the heavens, the work of thy fingers, what is man that thou art mindful of him?
You found evidence in the stars that shows the centrality of us in the mind and plan of God.
Yeah, essentially he gave us a piece of prime real estate here. I'm not saying the Earth is at the exact center, but I'm saying our galaxy is pretty much near the center of all this action. And he gave us a piece of prime real estate so we could see the rest of the cosmos and see that we have an important place in his plan.
My friends, if you'll just look at the evidence, even the red shifts in space show us how special you are to God. And I hope that this show today has brought you to a point of considering how much God cares about you. And I hope you all leave today understanding that it's God's view that He created you, and that too should be your worldview. It's been good having you with us, Dr. Humphreys. What a privilege to hear this great scientific information you've had to share and the incredible message it has for each of us. So friends, it's been good being with you. May you join us again soon on Origins, and until then, God bless you, my friend.
Thank you for watching this edition of Origins. If you'd like a copy of the PowerPoint information presented today, you can download a PDF file of program number 910 from our website at www.originstv.org. Or for a DVD of this series, send a $12 donation to cover shipping and handling and write to Origins, program number 910, Cornerstone Television, Wall, Pennsylvania 15148.
Origins is made possible by the faithful prayers and the financial support of you, our Cornerstone Television family.